So now let us start with our first model of the question today's. So the image of an object is placed in the air. The object is placed in the air, obviously. So formed by a convex refracting surface, formed by it's a convex refracting convex lens, is at a distance of 10 meters behind the surface. Okay, so image is being at a distance of 10 meters. It is behind that particular thing. The image is real and it is two-thirds of the distance of the object from the surface. The wavelength of the light inside the surface is two-thirds of the wavelength in the air. So all of them he has given. That means you need to get he is giving you the information regarding the refractive index. The radius of curvature is going to be something x by 13. He is asking what is it. So according to this image, the image is real. The image is real and is at two-thirds of the distance of the object from the surface. So it is at a distance of two-thirds of the distance from the object and the wavelength inside, that is the lambda in the medium, is equal to the lambda in the is a, with respect to the air. He is just giving that information. So that is lambda in the medium is equal to 2 by 3 times of the lambda in the vacuum. So now from this one, this is 3 by 2 is equal to lambda in the vacuum by lambda in the medium. Nothing but this should be representing your refractive index mu. So as we have got the refractive index, now it's a spherical object, spherical surface, spherical refracting surface. So mu by V minus this is 1 by U, which is in the air, is equal to the mu minus 1 by R. Where R is your radius of curvature, that is the one we need to find it out over here. Okay, now the distance of the object he has given it to be the sorry, image distance is 10 meters. Then two-thirds of this particular two distance of the object. So that means your object distance has to be how much, sir? It should be 15 centimeters. Or else that means V is equal to or U is equal to nothing but so 2 by 3 times of he is asking about this one, that is two-thirds of the image one, which is equal to the 2 by 3 U is equal to 10, that is U is equal to which is 30 by 2 in the sense which is 15 centimeters. This is how we will be getting the U value as 15. Now put down every value here. Refractive index is going to be here 3 by 2 by 10 minus this is 1 by 15 is equal to 3 by 2 minus 1. 3 by 2 is nothing but also equal to the 3 by 2 is also equal to the 1.5. So using that information also you can solve this one. So on solving this one, it's going to be the 3 by 20 minus 1 by 15 is equal to 1 by 2r. Or you just take the LCM and solve it. So you should be getting r is equal to somewhere around it should be the 30 by 13. That means your x is comparing to this one given question, then your x value has to be equal to the 30 centimeters. So this is your basic thing, right, sir? So x is equal to this value is 30. So remaining is a calculation part. The major important in this question is to identify the refractive index and to identify the object distance. Once you get these two values, it is comfortable to solve these type of the questions, please. An observer can see through a small hole on the side of a jar of 15 centimeters radius. Okay, at a point at height 15 centimeters from the bottom. Ash, okay, so it is been given. Fine. Now the whole height of the hole is going to be 45 centimeters. When the jar is filled with the liquid up to a height of some 30 centimeters, he wants to fill. That means it might be up to this particular point, sir. That means this distance should also be 15 centimeters. Okay. So now the same observer can see the edge. That means the light is been refracting from here. Edge of that means this light is been falling or traveling like this, and he can able to see this particular point. So this should be your normal drawn. Okay, so this is your light conditions. You can able to see this particular thing. Okay, so this is your light drawn. This is your normal to the surface. Refractive index of the liquid is going to be something n by 100. He is asking what is the value of your n. Now in the first case, this angle has to be the 45 degrees, or this should be the 45 degrees, because the all of them are going to be your and 15 degrees. This is 15 and this is also 15, so 45 degrees obviously should be. Now coming to this one as an R. So you have got this particular thing as an this has an some 30 centimeters, and this is your 15 centimeters, this is your 30 centimeters, this is your normal to the surface. So this is going to be the your R value. Now in determining the R value, this is going to be the your R. So how can I find this R value? Okay, so obviously your hypotenuse is going to be the 15 root 5. Okay, so this is your situation. Now apply the Snell's law to the corresponding situation, that is mu1 into sine 45 is equal to, this is mu2 into, it's going to be the mu2 into sine r. So mu1 is going to be the refractive index of this one, 1 in the air, and sine 45 is 1 by root 2 is equal to mu2 is the one we need to find. From the diagram, the sign for r can be written as an opposite side 15 by 15 root 5. So the index mu2 is equal to root 5 by root 2. So root 5 by root 2, or you can take them into combinedly, it will be approximately equal to somewhere around 1.58. It should be coming out because it is root over 5 by 2, in the sense root over 2.5. Root 2 is 1.414, so it is more than that particular thing. So we can go for this particular case, it is 1.58 or 155. So 55 to 6 it should be in between. So this value he has provided it as an 158 by 100 means, so your n value has to be the 158. Okay. So now this should be the next question, please. The distance between an object on the screen is, object and the screen is going to be the 100 centimeters. A lens can produce a real image on the object on the screen for two different positions between them. Okay, so between the screen and the object, the distance between those two positions is going to be the 40 centimeters. Is asking the power is going to be how much. It is a case of a lens displacement method or conjugate foci method for the determination of the focal length. So in the conjugate foci method or the lens displacement method, you will be fixing the object and will be fixing the distance between the object and the screen. That distance, this distance is a fixed distance, and that distance I'm representing it as an L. To obtain a real image, L has to be either greater than or equal to the 4 times of the focus. Now what will happen when you move the lens from object towards the screen? You will be getting an first image at the D1 distance, for example. This will be an object magnified image, and when you move still the lens to further distance, you will be getting an image as another diminished image. You will be getting, let that distance is going to be the D2. Now distance between these two positions is small d. This is called as a conjugate foci method. Very important model of finding the focus. From this one, focus formula can be written as an L square minus D square by 4 times of the L, where D is nothing but a difference between the two images distance. that is d1 and d2 dot d2 minus d1. So this one value given it as an 40 centimeters and the distance between L is been given as an 100 centimeters. Put down everything in the formula. So focus F is equal to 100 square minus 40 square by 4 into 100. He is asking power of this one. So this will be the 10,000 of you minus 1600 by this one is 400. Now your focus will be coming down to somewhere around, so 10,000 minus 1600, this comes out to be somewhere around 8400 and another zero, this is by 400. So if I remove these two things, so then I have put another extra one zero. So 84 by 4 in the sense it will be the 21 centimeters focus. From this one, power of the lens. In terms of the diopters or anything, power of the lens can be written as an that is 100 by 21 in the form of diopters. So then it should be somewhere around 4 point. So 76 if I mostly. So this can be written as an 476 by 100. So that means your n value has to be the 476 or 475 like that. So next one, sir. The vessel of the depth 2h is half filled with a liquid of refractive index 2 root 2. A vessel is there of depth 2h. He is filling with the half filled with that means up to h height. He is filling with the refractive index 2 root 2, and the upper half with a liquid of refractive index root 2. That means in a container he is taking the two liquids. So one is going to be the H occupying H. Another one is also H, but the upper liquid is having a refractive index of the root 2, and this one is 2 root 2. These are your refractive index. Let it be the mu 2, and this will be the mu 1. So now these two are immiscible liquid. Apparent depth of the inner surface of the bottom of the vessel. He is asking you the apparent depth, sir. So how do you find the apparent depth in this particular case? Apparent depth is equal to d apparent or anything. So d apparent is equal to real depth by mu. So what is your real depth is going to be the h, and the relative refractive index is 2 root 2 by root 2. So this is going to be plus with respect to the air h by this is going to be the root 2 by 1, anything like this. So now this comes out to be root 2 by 1. This comes out to be the d apparent is equal. So obviously it's going to be the 3. Okay, this will be the 3h by 2 root 2. Or the same thing if I want to write it as an 3h by 4 into root 2 times. Okay. So because I'm just converting the given information to the according to the option, please. So coming to the next type of the question, there is a small source of the light at some depth below the water surface of refractive index 4 by 3 in a tank. Large cross-sectional area is there. Neglecting any reflection from the bottom of the absorption, the percentage of the light that emerges out of the surface. So whenever a source is being placed at the beneath the surface of the water at some depth, what will happen? From this source, yes, the light will be emerging in the form of a circle like this. So he is asking total light that is being coming out of this particular thing. Let the radius of the circle on the upper half is going to be the r, and this distance is going to be the h. So this entire angle is an solid angle that will be which is represented by the omega. So from this one, solid angle that is omega is equal to. So this can be written as an that is 2 pi r square circumference into this will be the 1 minus cos. If this angle is going to be the beta, or some theta in this case, anything, though you can put it as some theta. So now from this one, the percentage of the light that is going out can be calculated as, that is solid angle by total surface area, which is 4 pi r square per an q into 100. That instance 2 pi r square into 1 minus cos theta by 4 pi r square. Okay, into 100 will give you the percentage. So remove all the common terms. What it will be left with? 1 minus cos theta by 2 into 100, which is equal to the 4 minus root 7 by 8 into 100. Okay, so now this will be on solving root 7 value. We can write it as an approximately somewhere around 2.8, that sort of a thing, or 2.7. So that will be equal to the, on solving, you should be nearly equal to the somewhere around 16 to 17% or 18%, that sort of a range it should be coming. So by looking at this one, the better option will be the option C. Now, question number 6. A convex lens of focal length 20 centimeters and a concave mirror is also there on the principal axis. Along the same line are kept 80 centimeters apart. So, what is the distance between them? Is 80 centimeters. The concave mirror is right to the convex lens. When an object is kept at a distance of 30 centimeters to the left of the convex lens, its image remains at the same position even if the concave mirror is removed. The maximum distance of the object for which this concave mirror by itself would produce a virtual image. So it has to produce an virtual image over there. Okay. So he has taken a convex lens like this and a concave mirror, and they are both of them are on the same principal axis. That means your concave mirror might be here out like this, and your corresponding distance is how much? uh, each other by somewhere around 80 centimeters here. Okay, so now he has given the focal length of this one also he has provided. An object is kept at a distance of 30 centimeters from the left here. So if object is kept at a distance of 30 centimeters and focus is equal to 20, 1 by f is equal to 1 by v minus 1 by u. That is 1 by 20 is equal to 1 by v minus of minus 1 by 30. From this relationship, 1 by v is equal to how much? So 1 by v will be equal to the 1 by 20 minus 1 by 30. Or on solving v is equal to, you should be getting it as in 60 centimeters. That means for an object which is placing at 30 centimeters distance, the light ray is falling on this surface and there has been converging at a distance of 60 centimeters. Okay, so now, but the total distance is how much, sir? 80 centimeters. So now from this one, what is the radius of curvature formula in this case? Radius is equal to 2f. Okay, so that means the focus, it's going to be the 20, where the f can be written as 10 centimeters. Okay, so this is your focal length he is asking of the concave mirror. Fine. Next one. Interference fringes are produced on the screen by illuminating the two thin slits 1 mm apart. That means he has given the small d, that is the distance between the two slits. Light of wavelength he has given, that is 632.8 nanometers. The distance between the screen and the slit C is 100 centimeters. This is the one he has given. If the If the bright fringe is observed on the screen at a distance of 1.27 mm from the central bright thing, then he is asking the path difference between the rays on reaching this particular thing. Okay, fine. So what is the path difference relation? Delta x is equal to d sine theta. Where in the YDSC experiment, since the angle is going to be the very small, this distance is y, and this is your theta, and this distance is capital D. Your sine theta can also be written as and tan theta is equal to y by capital D. So replacing everything d into this is y by capital D. Substitute every value in this case, please. Small d is equal to 1 into 10 to the power of minus 3. Young's modulus. Sorry, this is the sorry. Y is nothing but n. The distance between the central maximum and where the fringe is being obtained. So that distance he has given it as an 1.27 into 10 to the power of minus 3 by the distance of separation is going to be the 100 centimeters, or this is equal to the 1 meter. Now on solving this one, this will be the 127 into 10 to the power of minus 6, or which is equal to the 1.27 micrometers. Then it should be your first option. Now go for the next question, please. Question number 8. The light waves having the same way, the light waves having the same wavelength lambda in the vacuum are in phase initially. Vacuum are they are in phase initially. That means the phase difference of these two light waves, which are initially in the vacuum, the phase difference is nothing but n. If they are the same phase difference, or the phase difference is equal to 0. Fine. Then the first wave travels a distance of L1 through the medium with a refractive index N1. Second wave is going to travel a distance of L2 with a refractive index of the N2. Then he is asking the phase difference is going to be how much. As we know, the relation between the phase difference and path difference is phase difference is equal to 2 pi by lambda into path difference. So that means the phase difference we need to find out. For that one, path difference we have to get. Path difference is equal to, that is delta x is equal to the distance, that it is the difference between the distance traveled by the both the waves in their respective mediums. So the optical path of the first one is equal to n1 l1. Optical path of the second can be written as an l2 l2. So now this will be your delta x. So delta phi can be written as an 2 pi by lambda of n1 l1 minus n2 l2. So where is your option? This is the condition. Next question number 9 here. In a YDSC Young's double slit experiment, performing with a monochromatic light of the wavelength, monochromatic light means single wavelength, the intensity of the light at a point on the screen where the delta x, that is the path difference value, is going to be x, is k units. The intensity value he is giving it as a k units, and the path difference is equal to lambda. The intensity of the light at a point where the path difference is lambda by 6 is given by the intensity of the light we need to find at a particular point where the path difference is given by lambda by 6 is given by nk by 12, where n is an integer. So now what he is asking? He is asking us to find the intensity of the light. So how do you get the intensity of the light here? Okay, to get the intensity of the light, I is equal to maximum intensity, or this can be written as an I naught into cos square of 5 by 2, where I'm taking your maximum intensity value as some value constant k into this will be the cos square of what is the phase difference between them? Both of them is going to be the, so that to get the phase difference, delta phi is equal to 2 pi by lambda into delta x, or lambda by 6. Cancel this one, this will be the pi by 3. Substitute this pi by 3 in this case here. So it will be the pi by 3 by 2. So that will be your pi by 6. Then I is equal to 3k by 4, where k is equal to I naught. So or else, so if I multiply and write according to this equation, I have to multiply and divide with the 3. Then it will become 9k by 12. So this is the what he has asked. That is value of the n is equal to how much? Sorry, value of the n is 9. The numerator part he has asked, denominator is 12. Next one, consider an YDSC Young's double slit experiment. Consider an Young's double slit experiment as shown in the figure. What should be the slit separation D? D in the terms of the lambda. He is asking the D in terms of lambda such that the first minima should occur exactly in front of this one. That means this distance he is asking, this is the y, and y has to be how much? D by 2. This is what he is asking. So now what is the path traveled by the first light or the whatever the x1 or x2 or whatever it may be, just identify that particular thing. Okay, so x1s or x2s or anything, please note down that particular, this distance is going to be the d by 2 here. So let from the s1, the distance traveled is going to be the x1. X1 is equal to 2 pi by, or we need to go for how much distance it is. It is going to be the d, which is equal to the 2 small d. Directly you can write this distance exactly. Now second distance x2. So how can I get this x2? This is your distance from the x2. This is 2d, and this distance from these 2 points is going to be the d, and we need hypotenuse in this case. So this particular distance will become how much? D, and this is going to be the root phi d. So x2 is root phi times of the d. Now what will your part difference? Delta x is equal to x2 minus x1, which is root phi d minus 2d. So from this case, we need to find out the small d is going to be how much. Okay. So how do you get the small d value here? Since for the first minimum, the part difference should be equal to the lambda by 2. So from this one, take out the d out common. D is equal to lambda by 2 into root 5 minus 2. So this should be your answer. So what is your root 5 minus 2? 2 into. So this should be your 1 by lambda by 5 in 5 minus or root 5 minus 1. Okay, sorry, this should no, this is root 5 minus 2. Let me erase this one. Fine. Now, next one. The refractive index of the converging lens is 1.4. That is, mu is equal to 1.4. He has provided the focal. What will be the focal length? Is placed in a medium of same refractive index. So that means he's asking the is placing it in the same refractive index. Formula for the mu is equal to mu minus 1 or relative refractive index by, it is 1 by r or anything like this. So coming to the relative refractive index, mu relative is equal to mu in the water by mu. So mu is like this. This is equal to how much, sir? So the values of both of them are going to be the 1.4. So the same sort of a medium he has given, it will be 1. So then what is the 1 by f is equal to 1 minus 1, 0. So this is going to be the 0, or the f should be tending towards infinity. Okay, so this is our basic question. So your answer will be your, so this is the B, that is your infinite term, please. Okay, next one. So coming to the another question, this question concerned to the optics only, but it is the dispersive power form. The deviation 2 degrees is been there for the yellow rays when the prism is crown glass and flint glass are achromatically combined, taking dispersive powers of the crown and flint glass are going to be dispersive power means omega 1 is equal to 0.02 Omega 2 is equal to 0 point, that is 0.03. These are the two values that are being available right now. And the refractive indexes of mu1 is equal to 1.5 and mu2 is equal to mu2 is equal to 1.6. Yes, this is the information he has given in the question. Now from this one, since acromatical means its dispersion is not taking place, or the total deviation can be written as an your maximum deviation can be written as a deviation delta 1 minus delta 2. So how can you solve this one? Delta 1 minus delta 2 is equal to 2 degrees. This is our information which is given. Now, uh, your omega 1 dispersive power into delta 1 is equal to omega 2 into delta 2. So that means from this one, what you can find it out, sir? Delta 2 is equal to 10 into delta 1 by 10 into, this is going to be the deviation of the first one by deviation of the second case, if you can notice this one. So we have got the refractive indices, we have got everything. We need to find the angle of the prism is going to be how much. So how do you get the angle of the prism? Uh, that is deviation, the first one into 1 minus refractive index 2 by 3 is equal to 2 degrees. And from this one, or from this one, so what we can write, sir, here? That is delta 1 is equal to 2 degrees. Now when you go for the solving, you should be getting delta 1 is equal to 6 degrees. But we know that delta 1 is equal to mu 1 minus 1 into a1. From this is going to be the 1.5 minus 1 into a1. So this should be a basic condition. On solving this one, a1 has to be equal to the 120 degrees. So this is our question, sir. Next one, the thickness of the center of the plano convex lens is 3 mm, okay, and the diameter is 6 centimeters. If the speed of the light material passing through the lens is 10 power 8, he is asking what is the focal length of this particular thing. He is asking what is the focal length of this one. So a thickness of a plano convex lens. Let us imagine this is a plane surface and this is a convex surface. So the thickness of the plano convex lens is going to be how much, sir? Which is going to be the 3 mm. Okay, so in this one, this distance he has given. Okay, so from the center might be here. So from the center to the edge, that distance will be equal to nothing but the radius. And here also it should be in the other case also it should be the radius. And this should be your r minus x if x is equal to 3 mm. Fine. So now how to approach to this particular question. So now why can't we take the radius is also something around diameter 6 means this is also 3 centimeters, this is 3 mm. Why don't we go for the right angle triangle here? What is your right angle triangle is? This is going to be the A, this is B, this is going to be the C. Solve for the right angle triangle. That will be the 3 square plus R minus this is 3 mm. This length is only 3 mm. Whole square, okay, is equal to R square. From this case, we can solve it as an expand this one. This is 3 square plus R square minus 3 mm. Sorry, 9 mm square. Next one minus This is what is the other term? This is 2R into 3 mm. Okay, so this is what we are solving, sir. This is equal to the other side. Okay, leave it, no problem. So these three things can be removed here. From this one, thickness T is equal to 3 into 3 mm square is equal to R square. Okay, na? So from this one, approximately your radius of curvature comes out to be the 1.5 centimeters. So radius of curvature is known. Then the focus length can be 1 by f is equal to mu minus 1 into 1 by 15. So focus f will be equal to the 30. So this is the one he is asking here. Now your friend is having an eyesight problem. Here it's a real problem. She is not able to see clearly the distant objects. If we cannot see the distant object, it should be the myopia. Uniform window mesh, it appears to be her as a non-uniform distortion. So distortion means it should be astigmatism. The doctor has diagnosed the problem as myopia and astigmatism. Myopia and astigmatism. So what is this astigmatism is? Astigmatism is nothing but a distortion of the light. That is the blurriness of the light will be there. While seeing any object, that means when you see any particular object, its image will be seen to you as distorted image. So it's a common. He cannot able to see the distant object, and as well as the image is distorted. That means he should have both the problems of the myopia and astigmatism. So both the problems are going to be the in this case, please. Next one, three rays of light, namely red, green, and the blue, are incidented on the face. It's a normal incidence right angle. The refractive indices of the different materials he has provided 1.27, 1.42, and 1.49. This should be for the red, this should be for the green, and this should be for the blue. Okay, so these are the refractive indices also he has given. The color of the rays that are emerging from the PR. So which rays will emerge from here? The rays which do not undergo the total internal reflection, that means whatever is going to be the rays that are going to be falling, if that angle is going to be the critical angle or more than critical angle, then that rays is going to be reflected back into the same medium, right? So now our now primary duty is to find out the, as he has given the refractive indexes of different cases, we can find the angle of incidence is going to be how much. So now from the Snell's law, sin C can be critical angle is equal to 1 by mu, or from this one, C is equal to sine inverse of 1 by mu. So what can be our angle here? So for the given situation, see if I take this one, or the C value has to be greater than or equal to the 45 degrees. That means for the red, C is equal to, that is sine inverse of 1 by, this refractive index is 1.27. So this is for the red indications. So when I solve this one, we should 1 by 1.27 and just go for this. Then the angle C will be somewhere around 52 degrees for the red, and for the violet it will be 45 approximately, and CV for the blue is going to be 42 around, it should be according to their given values. So now for any value which is the above this one, the so which ray is going to be emerging out? So red ray will be emerges out, and the remaining green and the blue rays will be refracted back into the same medium. That is, those two are undergoing the total internal reflection. So coming to here, the fringe width he has given, that is the beta, produces was produced. Two slits are separated by a 1 mm apart, that is small d he has given. The screen is placed at the 10 meters, which is capital D also provided. The wavelength of the light he is asking, that is the beta is equal to formula lambda into capital D by small d. This is your beta value, sir. So now The wavelength he is asking. Beta is equal to 6 mm, 6 into 10 to the power of minus 3. Okay, next lambda. We need to find it out. Capital D is how much, sir? So this is the value. It's going to be how much? 10 meters away. He has given the question here. Capital D is 10 meters away. By small d also he has given in the question. So what will be the small d value? 1 mm apart. That is 1 into 10 to the power of minus 3. Lambda. Lambda will be equal to the how much, sir? 6 into 10 to the power of minus 7 or 600 nanometers or it is 6000 angstroms. Okay, so whatever the answer he is asking in terms of the nanometers only now. So write down the nanometers. So that will be your nearby answer. Right, sir? Next one, question number 17. The speed of the electron in an electron microscope, he has given the velocity here. If the protons having the same speed are used instead of electrons, if protons using the having the same speed he is asking instead of the electrons, the resolving power of the scanning proton microscope will change by a factor how much? So your resolving power is equal to it's going to be proportional to the 1 by lambda. Can I write it? Or lambda is equal to h by me. Lambda is equal to h by or momentum p is equal to h by lambda. Lambda is equal to h by momentum. Or this can be written as an h by mv, mass into velocity. That means your resolving power rp is also mv by h. So sorry, this is going to be the mv by h conditions. From this one, you can say that resolving power is proportional to the mass. Resolving power is uh, resolving power is going to be directly, that is rp, is directly proportional to the velocity. And the next one is going to from this one. Okay, these are your conditions. That means as the resolving power is directly proportional to the mass, so mass of the element is and how much? 1837 or 1834. You can write it as and to remember it easily. So next case, in YDSC experiment, width of the slit is 3 times. That means what he has given, sir, A2 is equal to 3 times of A1 he has provided. The amplitude of the light coming from a slit is proportional to the width of the slit. So he is asking the ratio of the maximum to the minimum intensity. What is the formula for the I maximum by I minimum, which is equal to I maximum by I minimum can be written as an A1 plus A2 whole square by A1 minus A2 in terms of the amplitude. I'm dealing this one. So this is nothing but an 3A plus A1, which becomes as an 4A1 and the denominator is 2A1. This is the one. So A1 cancels. This goes for 2 times. Okay, and this is the whole square. So how much it should be? 4 is to 1 ratio. So they have to be in the ratio of 4 is to 1. That is the maximum to the minimum. And unpolarized light. And unpolarized, this is the last previous question. An unpolarized light beam of incident on a polarizer in a polarization experiment, and the intensity of the light beam from the analyzer is measured to be 100 lumen. He is asking if the analyzer is rotated around an angle, or so rotated around the horizontal axis by 30 degrees in clockwise direction, the intensity of the emerging light will be how many lumen he is asking. So now from the first resolving power, fine. This is the one we need to get it. So unpolarized light is be there. First, what is happening? Let this be your polarizer. Fine. So on this polarizer, a light is being incidenting through this one. So immediately it comes out to be the I naught by 2. Again, it is falling on the other polarizer, which is at the same angle. Then how much will come out in this case also? I naught by 2 only. And I naught by 2 value given as an 100 lumen. Now the analyzer is rotated by 30 degrees. That means polarizer is in the same position. You are rotating an analyzer by 30 degrees in clockwise direction. Okay, so intensity is going to be how much? So here it should be I naught by 2, here it should be I dash or I1. I1 is equal to, fine, so I naught by 2 into this has to be the cos squared of 30 degrees. This is your Mule's law. So this is I naught by 2 is 100 and cos square 30 is 1 by, sorry, 3 by 4. So since it is 3 by 4, you can have the final value as 75. So this is the condition. Next one, in a source of light, if the source of the light of the YDSC experiment is changing from the red to violet, since you are changing, what is happening? Lambda is changing, lambda of the red and lambda of the violet. Velocity is not going to change, only the lambda will be changing. Okay, and the lambda and the wavelength of the red is going to be 8,000 around, and wave violet is 4,000. So that difference is very important here. Okay, so one is going to be around the 4,000 angstroms, another one is going to be the around 8,000 angstroms. So these are your respective wavelengths of the source. As wavelengths are changing, small d and capital D, all of them are same. Only the wavelength is which is the one changing. So small d and capital D are varying. So intensity should not make any difference here. Intensity should not change. The only change that can happen in the fringes by because fringe width formula is lambda into capital D by small d, and these two values are changing. So there is every chance that fringe width will be changed. It doesn't concern to the any other things, please. Mm, okay, next one. In BIDSA experiment again, two slits are separated by the distance 2 mm small d. The screen is placed at a distance of 1 meter, which is capital D. When a light of wavelength 500 nanometers is used, what is the the fringe pattern will be he is asking. So what are the things he has given? Lambda he has given capital D small d, beta is equal to fringe width is equal to lambda into capital D by small d. This is 500 nanometers, 10 to the power of minus 9 into capital D is going to be how much? 1 meter by 2 into 10 to the power of minus 3. So now solve this one. This will be how much, sir? 25 into anything like this, 10 to the power of minus 6 or anything. Readjust this one so that you can have this. So 500 by 2 is going to be the 250. Right, sir. This is going to be the 250 into 10 to the power of minus 6 in the sense, which is 250 microseconds. Fine, sir. So this to 0. Or if you want to convert it into the millis, then it will be the 0.25 mm. So that will be your final answer, which is capital D. Okay, now, so with this, we can complete the questions, whatever are there. So ray optics is a very, very important question. We can expect two questions, one from the ray optics, another from the wave optics, where wave optics is a very simple and small chapter. Only three concepts will be there, that is interference, diffraction, and the polarization. You can expect one question compulsory over there. So please go through them. It's a very, very important thing. All the best to you, everybody.